So here I'm gonna show you example. Now, yeah, this one. Do you remember? Last letter. What is it? So this function is for short term. Yeah. This is for short element. And you have an L here. L is right. This. Right. So you want to check if this candidate is inside a right L. You want to return true. So otherwise, if this candidate doesn't exist inside here, inside L, so you return false. Alright? Alright? So here, so we have three cases. The first one we call the best case. This happens when the candidate is the first element in L. And the worst case is candidate is the last element. So why is the worst case? Because we need to go with all the elements inside L. To get the answer is 2. Right? So at the average, so easy. It's just you calculate the best case plus the worst case divided by 2. Yeah. It means in the middle L.
이것도 마찬가지로 실제 타이밍을 계산하는 것에 약간 좀 의미가 없는 이유 중에 하나가 될 수도 있겠는데, 그러니까 인풋이 어떠냐에 따라서 계산하는 횟수나 그러니까 또 계산하는 데 걸리는 시간이 차이가 납니다. 그러니까 지금 보시면은 지금 함수가 search for element 이렇게 해서 L이라는 리스트랑 candidate라는 걸 입력받고요. 그러니까 포문을 사용해서 L 안에 있는 걸 확인하는데 엘리먼트를 하나하나씩 가다가 캔디데이트랑 같으면 true를 리턴하고 없으면 if문과 for문을 벗어나서 이제 false를 반환하게 되는 거겠죠. 코드는 이해가 되실 거고, 캔디데이트가 이 L이라는 리스트 가장 앞에 있으면 어떨까요? 한번 딱 비교해보고 같으니까 true를 계산하고 끝이죠. 그러니까 이 경우 베스트 케이스에서 한 번에 계산을 하고 끝납니다. 만약 그게 리스트가 없다면요, 또는 그냥 가장 마지막에 있었다면요, 그 경우는 worst case가 되겠죠. 왜냐하면 length of L만큼의 계산을 했다는 뜻이니까요. 그리고 적당히 중간쯤에 있는 경우가 이제 에버리지한 케이스가 되겠죠. 그냥 보통의 경우. 세 가지 케이스로 나눌 수가 있습니다.
So the question is how many operations you need to get the best case. In the best case, how many operations you need to do?
베스트 케이스를 수행하는데 얼마나 많은 알고리즘 계산이 필요하죠?
How many operations? You hit the candidate at the first element. So how many operations you need?
얼마나 필요하죠? 자신 있게 말씀을.
Answer? One, yeah, that's it. You're right. Because the candidate is the first element in L. So you hit the first element in here for the first time, for the first iteration, and you return true. That's it. You finish. Alright. But how many operations you need in the worst case?
워스트 케이스의 경우에는 알고리즘 몇 번을 수행하는 거죠?
This is the number of elements in L.
This is the length of L.
Yeah, the length of L. Yeah, the average is the best case plus the worst case equal. Okay. So, but in computer science, in programming, every time, we only worry about worst case. We don't need to spend much time for the best case and average. We only take this one. Because if this one happens, it will slow down your program. For example, in the best case here, you only need one operation in the best case. But if your right here have around 1 billion elements, what happens here? You need 1 billion operations. So we slow down your code. Right? So you don't need to worry about this one.
보통 이제 이거를 그 세 가지 케이스 중에서 신경을 많이 쓰는, 그러니까 집중하는, 해결하려고 하는, 노력하는 케이스는 월스트 케이스의 개수입니다. 그러니까 왜냐하면 월스트 케이스는 가능한 일이기 때문이에요. 그리고 가능한 일이기 때문에 실제로 연산을 많이 늦출 수가 있죠. 컴퓨터의 작동 속도를. 그렇기 때문에 워스트 케이스에 대해서 관심을 보통 많이 갖습니다.
Alright. So we need, because the timer is not a good solution, so we need another way to measure the complexity of your program. And the second way is people. People need a way to measure the worst case. Right? We don't only worry about this one. So, and keep in mind that bit O is used to evaluate the algorithm, not the machine or the implementation. So, it means the bit O for if you implement your algorithm in Java or in C, bit O always the same. Right? In Python, it's the same. Because you evaluate the number of operations you need to run your program. So then you get a bit O. So bit O of, for example, here you have a function fn here. This is a function fn here. So the bit O of fn is a family of functions gn, in which when n goes to infinity, gn always bigger than fn. So if you confine Gn and the constant number C, somehow C multiply Gn over bigger than Fn. So Cgn equal to bit O of Fn.
Actually, I can't understand either. 그러니까 지금 그 worst case를 describe 하는 하나의 방식이죠. 빅 O 노테이션이라고 표현하는데 뭐라고 설명해야 될까요? 개수. 그러니까 n제곱은 항상 n보다 더 큰 거예요. 그러니까 n제곱 플러스 n은 그냥 n제곱인 거예요. 이렇게 말씀을 드리면 이해가 되시나요? 네. 그렇습니다. 그러니까 n이 무한으로 지금 가고 있는데 So you were saying about the Fn is the same as O, big O of Gn, right?
Yeah, Gn with a bit O of Fn.
It's same.
Same?
Is it same?
Same what?
So you're saying about it's the same.
No, it's not the same. It's not the same.
It's not same?
Yeah, but equal symbol, it doesn't mean the same.
Yeah, but
It's just a notation.
okay.
Yeah. So it means that the big O of Fn always bigger than Fn.
Gn is bigger than.
Yeah, it means the big O of Fn always bigger than Fn. Big O, it means something bigger, right? Always bigger. Yeah. So that's it. You can repeat this one at home. In here, we focus here. I will show you example. So, if you have this one, so the big O of this one is this one. You know why? Because when n goes to infinity, even when n becomes extremely big, so s squared will be extremely bigger. I mean, bigger times bigger than 2 multiplied n. Right? And also bigger than 2. Yeah, of course, because n goes to infinity. So 2 becomes very small compared to infinity. 2n very small, tiny compared to n squared. Yeah. So because you don't worry Similarly, this one is very small compared to this one. If n goes to infinity, right? And this one is constant. You don't need to worry. We never ever worry about the constant because you worry about how long you need to run your program when your input goes to infinity. For example, n can be the number of elements in your array. So when the number of elements go to infinity, how long your program needs to run? Okay? How about this one? So, lower it, okay, all the way million times smaller again. So we don't need to worry about this one. Don't worry. This one is constant, no, right? How about this one? So here we have n here, and we have a log n. Now this one is yeah, and log n bigger than here. Alright, see that? Because this one constant, and when n goes to infinity, log n absolutely bigger than 300. Right? And here, see that? This is formation function. And let's keep like this one because the number here is a constant. So
여러분들이 고등학교 때 미적분 배웠던 거 생각하니까 유니트 n이 무한으로 갈 때 가장 도미넌트한 그 항만 남겨두잖아요. 네. 그 개념입니다.
So we have some rule, some basic rule to calculate it all. The first one we call it addition. More than addition, law of addition. So what does it mean addition? Addition means you want to give addition when you have two segments for loop. So this one and this one, they are separate. They do not next to each other. After you finish this one, you will run this one. Okay. So in here you want to use law of addition. Because this one is n step n operation. So you need n iteration. In here you need n square iteration. And then you use law of addition here. And then you have this one. But, like I said, n squared is extremely bigger than n when n goes to infinity. So we ignore it, we just take this one. Okay.
그러니까 지금 여기 나와 있는 5fn 더하기 5gn 5fn 더하기 gn이랑 지금 똑같은 그냥 이것만 이해하시면 될 것 같아요. 그러니까 더하기 법칙인데 지금 보시면 아시겠지만 n번 그 다음에 그러니까 처음 for 루프는 노테이션이 5n이고 그 다음 5n 제곱이죠. 이 경우 5n 제곱 더하기 n과 같고 말씀드렸듯이 n을 무한으로 보냈을 때 도미넌트한 녀석만 남겨준다고 했으니까 항만 n 제곱만 남겨요. n은 n 제곱보다 매우 작으니까요.
So the second rule is multiplication. So this one is, you see that? We have in the loop here, in the loop. And this one is out the loop. So for each iteration of our loop here, we want to still track n count. Yeah, n count. This n. They are next to each other. It's different from this one. They are separate. They are separate features. This one is a mess. Some you want to do multiplication. Here. Alright, that's it. Just multiply. So this one, I'm sorry, this one is away. I'm sorry, this one is away.
Yeah.
This one is away.
It's changed.
Yeah. It's change. So finally we have a away, multiply away equal this one. We cannot ignore this one because we don't know what is the exact value of n.
곱하기 법칙입니다. 그냥 간단하게 그러니까 지금 있는 for loop는 여기는 이 for loop랑은 다르죠. 그러니까 이 for loop는 두 개, no. I'm gonna explain. 지금 이 for loop는 두 개의 for loop가 지금 얘 i에 대한 for loop 실행되고 j에 대한 for loop가 실행되죠. 이 경우는 인덴테이션을 제거하죠. i 안에 지금 j에 대한 루프가 있는 거잖아요. 그러니까 n번 연산 안에 각각의 n번에 n번씩 연산하는 거니까 지금 5n 곱하기 5n이죠. 이 경우 그냥 5n 곱하기 n과 같습니다. 이 경우 n이나 n은 그대로 남겨두셔야 돼요. 왜냐하면 다른 문자잖아요.
So we have some kind of nested class. First one is constant. O1 it doesn't mean you need one operation to run your program. O1 is mean the time you need to run your program is constant. For example, you need 1,000 operations to run your program when number of elements is 2 elements. But when number of elements go to infinity, you still only need 1,000 operations. You don't need more.
그러니까 지금 5, 1이라는 거는 항상 정해진 숫자죠. 이거는 뭐 there's no best case or worst case or just 항상 그냥 같은 수의 연산만을 수행한다는 의미가 되겠죠.
So and the other one is similar. So when your input go to infinity, your running time will be extended. So you need more operations to execute your program when n go to infinity. So this one is slower than the first one. This one is slower than this one. This one is slower than this one. This one is slower. And this one is extremely slow. So in practice, if your program belongs to this one, you need to consider. You need to find a way to speed up or optimize your algorithm. So this one is a good option. This is very good. This one is extremely good. This one is excellent. This one amazing. Okay.
말씀드렸듯이 지금 현재 보면 아시겠지만 밑으로 갈수록 더 훨씬 시간 복잡도가 더 큰 겁니다. 그러니까 지금 TI의 말로는 n의 세제곱, n의 4제곱 이런 식으로 갈 경우에는 좀 고민을 해볼 필요가 있다 이거예요. 더 좋은 방법이 있지 않을까? 이런 식으로. 지금 맨 밑에 있는 경우는 지금 익스포넨셜이죠. 그러니까 지수죠, 지수. 그러니까 이 경우는 압도적으로 계산할 양이 많아지는 거. 이거는 좀 다들 어느 정도 이해하실 거라고 생각합니다. 참 잘하시잖아요.
Okay, so I show you some example here. This is the number of operations. You need to calculate when number of input here. This is number of input, and this one is number of operations. So you can see that when for O1 here constant, when n equals to 10, number of operations is 100. 1 here 1 and 1 still 1. This is constant. And then here you see that it grows bigger. And for this one, it's exponential function. You see that? When the input is 1,000 here, it's this number. But when go to million here, I don't have enough space to write down this number.
지금 보시면 아시겠지만 방금 밑으로 갈수록 더 컸잖아요. 시간 복잡도 그 빅 오도테이션 더 크랬잖아요. 지금 보면은 n이 10에서 1000까지밖에 안 갔는데도 차이가 엄청 극명하게 드러나요. 그렇기 때문에 중요하죠. 실제로는 이거보다 훨씬 더 많은 데이터를 다룰 때도 많으니까요.
Sorry.
Seriously,
yeah. So we have very famous story about time complexity. We call that salmon problem. Yeah.
시간복잡도에서는 흥미로운 문제가 하나 있는데 salesman problem이라는
Yeah.
문제예요.
So in this problem, you have one shipper, one delivery guy, and you have n destinations in a city. So it means this delivery guy have to go through each destination one time and deliver the package to the customer, to each customer. The question is how long? How long? I mean, in the timing, how long he need to go? How long he need to go on the destinations and get back to his company? So you want to find the shortest ways. It means the way that consume less time, less money, less energy. Yes.
이해하셨을 거라고 생각하는데 지금 보시면 각각의 점들이 목적지라고 생각합니다. 지금 쿠팡을 생각하면 돼요. 쿠팡.
Yeah, coupon.
각각의 점들이 지금 들려야 하는 한 번씩 들려야 되는 장소고요. 제가 움직일 거예요. 그리고 다시 돌아와야 돼요. 그러니까 이 경우 지금 보시면 알겠지만 어찌됐든 있는 이 선의 길이의 합이 짧으면 짧을수록 좋겠죠. 짧을수록 에너지도 덜 들고 시간도 덜 들고 더 많은 일을 할 수 있을 거고. 여하튼 지금 그거에 관한 문제라고 이해하시면 됩니다. 그러니까 초점을 갖는 거는 어떻게 해서 이 점을 가장 짧게 이룰 수 있는가. 왔다 갔다 이렇게 하면은 이거 비효율적이겠죠?
So you know coupon guarantee deliver your package in 24 hours. Just 24 hours, whatever you order. So this is extremely amazing because they spend a lot of efforts to solve this one. This one, until now, the general solution for this problem is still vacant. It means we don't have a clear answer for this one. But we can try to find optimal solution for specific area, specific country, specific conditions. Yeah, but we don't have the general solution. So if you can solve this one, you will become a billionaire soon. I guarantee that.